This is really the biggest and most complex scientific project ever undertaken. The whole 27-kilometer circumference is aligned to better than a tenth of a millimeter. But the way that we cool the machine down is very unusual. We are using superfluid helium, which is a very, very odd liquid. It's a quantum liquid. For instance, if you put it in a beaker on your table, then the liquid would just crawl out of the beaker. Obviously, it's a terrific engineering challenge to make this completely fail-safe. And this is an essential feature of the LHC. I think it's the first machine in the world that's got the capability of destroying itself.
So this is Scott Grid. This is where we're about to receive all the data from the LHC. You can see this is a typical regional data center. This is where we hope we'll see the first data which might tell us all about the Higgs.
In order to handle the large amounts of data which come from the LHC, we decided to build a successor to the World Wide Web, and we called it the Grid, which incorporates sites around the world, including Glasgow, and this enables us to meet the analysis challenge.
The detector for a Large Hadron Collider is constructed a little bit like a set of Russian dolls. We in Glasgow have been working on the vertex detection, the close-in silicon tracking. We're in the innermost layer of this. You can see how it's designed as a mosaic of tiles. Each of these tiles can detect and accurately measure the position of particles going through it, and this is done 40 million times a second. There's a lot of intricate work to do. Across each join there are something like 500 little gold wire joints.
Now, if we want to make a top quark at the Large Hadron Collider, when we start up this project at Atlas, when the first collisions occur, then our role in Birmingham in contributing to the detector will become vital. Because one of our key roles is to try to decide which of the collisions to record onto computer and process and try to analyze.
I'm working on minimum bias trigger and trigger for first physics, and actually looking at how the trigger biases the events that we collect.
I'm looking at the phi meson, which is a particle that will be produced in the collisions, and it's made of a strange quark and an anti-strange quark. And these are really interesting because things that have strange quarks in could be a signature of a quark-gluon plasma.
Everybody from all over the world is going to come to Europe, and that's going to be the center of all the activity, and I'm right in it.
People have a lot of stereotypes about people doing physics, that they should be all male and that they should be wearing cardigans with patches on and glasses with tape around the middle. And no, we're not like that at all. So well, some are, I suppose. But
for me, as a theoretical physicist from Cambridge, I've got to look at the results after they've come out and actually after they've been published. Theoretical physicists think in a peculiar way. We have on the coffee tables, we have glass and pens there, and there are blackboards everywhere. It's very annoying not to be able to write something down if you need to. I'm sure I dream about the mathematics in my sleep, and I've solved problems in my sleep. CERN is a hot pot of all the best brains around that are interested in particle physics. It's the temple of physics, and all the top acolytes go there.
Time can behave like another direction in space under extreme conditions.
The UK, through the Science and Technology Facilities Council, is one of the biggest contributors to CERN and hence to the construction of the LHC. And I'm very glad to say that the British government has been very supportive of CERN and the effort to build the LHC all through the times when it seemed like it was going to be impossible to bring the project to a successful completion.
The two big experiments, CMS and Atlas, both have significant UK involvement, as well as the other two more specialised experiments, ALICE and LHCB. So we're really everywhere.
By the UK being involved in this exciting project, it actually opens up a lot of opportunity for young, bright physicists and engineers to really be involved in cutting-edge technology and cutting-edge research.
I myself am funded by STFC, and they have funded me to come out here to CERN and spend a good deal of my PhD out here where it's happening.
This work, which has been going on for 20 years, and the last 10 years have been quite active. And you see, people have been so motivated that they were working like mad, more than what is by regulations. And I think they will achieve something they can be proud of. I think as a DG, I think I should be not so much proud and thankful to all these guys which have been working so hard. Because without all this motivation, all this dedication, nothing could have happened. And now we are ready to see the benefits. The LHC is a compulsory tool. Without the LHC being built, we will know that a big part of the knowledge is missing and we'll have no way to discover it.